Okay, so on page 4, we are going to solve initial value problems. And basically here you are given an initial value, and what that means is you're given a value of x and y, and you're trying to find the equation at a particular point. So we've done problems similar to this before, and we're going to use separation of variables to do that. And actually I'm going to add a little bit of directions or instructions to this first problem. We want to give the solution in the form of x equals g of y. And basically what this means here is we want to solve this equation once we're finished for x. So it needs to say x equals. So the first thing that we want to do, according to what we did on the previous page, is we want to get all of our y's on the left and our x's on the right, which means we need to add 3x squared and multiply by dx. So that gives us 4y minus the cosine of y dy is equal to 3x squared dx. So now we have our variables separated. Again, separation of variables. So then what we want to do to get the general form of the equation is integrate both sides. When we integrate the left side, the integral of y is 1/2 y squared. So 4 times 1/2 will be 2y squared. And then when we integrate the cosine of y, we end up with the sine. So this is minus the sine of y. And typically we would write plus c, but remember what we talked about on the previous page, you're going to write plus c on the right hand side with our x. So it's just one big fat c for everything. And this will be equal to the integral of x squared is 1/3 x cubed. 3 times 1/3, they cancel out, so we're left with x cubed plus c. So this right here is the general equation. Okay, what we want is the specific equation, and we are given this point right here so that we can find c. So we're actually going to plug in this 0 for x and 0 for y, and I'm going to show you the entire substitution so there's no confusion. So we have 2 times 0 squared minus the sine of 0 is equal to 0 cubed plus c. Turns out that c is equal to 0. So now our specific form of the equation is going to be 2y squared minus the sine of y is equal to x cubed. Now in this case, this is a specific form of the equation, but based on the directions that I altered from above, we want x to be equal to g of y. So we need to solve this for x, which means we need to take the cube root. So x is equal to the cubed root of 2y squared minus the sine of y. So you need to make sure that you read the directions so that you know what it's asking for. And I just wrote right through that problem. Okay, so here what we're looking at is through this point 0, 0. Okay, so we're looking for this portion of the graph, which is the darkest. So that's just what this shows right here. Okay, so in this next problem, in B, I'm going to add again some instructions. We want to find the solution in the form of y is equal to f of x. So this is what we're used to. We want to solve our equation in the form of y equals. Okay, and this is actually a very interesting problem because there's something that's going to come up. So I'll show you how to do that. So in this case, this equation is written in the form of y prime. So we need to rewrite that first as dy dx. So we want to rewrite this as dy dx is equal to 6x minus x cubed over 2y. So again, with the separation of variables, we're going to multiply by 2y to get this over here, and multiply by dx to get this over here, to separate the variables, getting y on the left and x on the right. Okay, totally separated. So now we need to integrate both sides. Okay, integrating 2y dy, this becomes y squared, is equal to, this is 1/2 x squared, so this would be 3x squared minus 1/4 x to the 4th plus 1 big fat c. Okay, so again, this is the general form of the equation. So we want to know our C value when x is 0 and y is 3. Okay, so we're going to plug in, so let's plug in. So plugging in 0 for x here and 3 for y, this becomes 3 squared is equal to 3 times 0 squared minus 1/4, 0 to the 4th plus c. On this side, these basically both go away, so we're saying that c is equal to 9. So we're going to plug that in right here. So the specific form of the equation that we're going to use is y squared is equal to 3x squared minus 1/4 x to the 4th plus 9. Okay, now, in the directions, it says that we want to solve for y. When we take the square root, what some of us typically forget is that you have to write plus or minus. So when we take the square root, we have y is equal to the positive square root of 3x squared minus 1/4 x to the 4th plus 9. And then we have the negative. Now, the issue here that we have to look at is what point does my graph go through? In this case, my graph goes through the point 0, 3. So I need to make sure that when I plug this in, this is what I get. So when I plug in 0 for x, 0, 0, the square root of 9, we want the positive, this is positive 3. When I plug in 0 for x here, which is the negative, I get 0, 0, square root of 9, I get negative 3. This one does not work with this point, so this one is not the one that I'm going to choose. This right here is my specific answer based on the fact that this part of the graph goes through this point. So you need to make sure that you're checking that when you're taking the square root. Okay, in this last problem, we have a very similar scenario. Okay, and when we solve this, we need to make sure that we are going through this point right here. So here you have e to the x squared y prime plus x is equal to 0. So the first thing I need to do is rewrite y prime as dy dx. So we have ex squared, or to the x squared, y dy dx plus x is equal to 0. So now I need to separate the variables, which means I need to subtract x. When I divide by this e, you need to rewrite this as a negative exponent. You never want anything in the bottom, especially with variables, in the separation of variables. And this I don't need to move at all. So what we want to do is keep these two together here, and this, and this need to move to the other side. Okay? So we've got y dy is equal to subtracting x, dividing by this, which is essentially times e to the negative x squared dx. Okay, so when we integrate both sides, this side is easy. This side is actually a u sub. Okay, so this will become 1/2 y squared. Okay, on this side for the u sub, we're going to say that u is equal to negative x squared. So that means I need to get rid of this and this. So when I take the derivative, du is equal to negative 2x dx. Here's my negative, here's my x, and here's my dx, which means I need to get rid of the 2, or I just need to move it. So 1/2 du is equal to negative x dx. Okay, so when I'm integrating, this is equal to 1/2 times the integral of e to the u du. Okay, this should be easier, and this should also be a reminder. So the integral of e to the u du is just e to the u, resubstitute. So you have 1/2 y squared is equal to 1/2 e to the negative x squared, and then of course plus c. there's a couple of different ways that we can do this. When we multiply by 2, you have y squared is equal to e to the negative x squared plus, this is just going to be double c, so it's just still plus c. Okay, now the issue here is that I need to find c. So I need to go back up to the top and plug this in. Okay, because this is the general form of the equation, I need the specific. So when I plug in 0 for x and I plug in -2 for y, actually I should have done it here. So let's do it in this one first before we solve this. So let's find c. So ignore this right here. So when I plug this in, I'm going to go over here. We have 1/2 -2 squared is equal to 1/2 e to the 0 plus c. So this becomes 2 is equal to 1/2 plus c. So then in this case, this is 4/3/2. C is equal to 3/2. So before I multiplied by 2, what I should have done is I should have solved for c. Then I can easily multiply by 2. Let's get rid of this. Actually, I can just put this in here. Okay, so I'm going to put this back. 1/2, put this back, 1/2, put this in here, 3/2, like that never happened. It did, but let's pretend like it didn't. Okay, now it would be easier when we multiply by 2, because then it gets rid of any fractions. So multiply by 2. So this becomes y squared is equal to e to the negative x squared plus 3. That looks so much better. Okay, so I didn't give you a change in instructions, but what I want you to do here is get it in the form of y is equal to f of x, okay, which means basically I want to solve for y. And the reason why I want to show you this is because if you look back at this previous problem, here we went through this positive point, it was the positive square root. Here we're going through a negative y value. When you solve for y is equal to the positive square root of e to the negative x squared plus 3, and y is equal to the negative square root of e to the negative x squared plus 3. So when I plug in 0 for x, this becomes 1 plus 3 is 4. The square, positive square root of 4 is positive 2. We want the negative. So I don't want this one. I want this one.